Alright, welcome back once again. And the time has come for us to move back and forth from the polar coordinates that we can now plot to the rectangular coordinates that we can also, hopefully from a long time ago, be able to plot. And now we can go from one to the other. And so going from polar to rectangular isn't that bad, and that's because, well, we kind of have the definition just straight up given to us. If we know r and theta, we can get the values for x and y rather straightforwardly. So for example, suppose I want to convert the polar coordinates 3, 2 pi over 3 to rectangular. So let's see here, that puts me with r of 3. Let me clear this trash. And so this spot right here, I need to convert that spot which we found in polar coordinates to rectangular. And the way we can do that is what we have been able to do for a long time now. Right, we know the radius is 3. And we know this angle is 2 pi over 3. So using the right triangle approach, or the definition I was just giving you, right, we know this interior angle is pi over 3. We know we're in the second quadrant, so the x-coordinate's negative and the y-coordinate's positive. Do the appropriate trig, either triangles or definitions or unit circles or what have you, and you'll be able to conclude that the x-coordinate is negative 1.5 and the y-coordinate's about 2.6, exactly 3 root 3 over 2, but approximately about 2.6. And that's it, right? To go from polar back to rectangular, it's not that big of a deal. We just inscribe our appropriate right triangle, drop a vertical to the x-axis, be it down from a point up here or up from a point down there, and we can always convert from polar back to rectangular. But how do we go from a rectangular point to a polar point? Nope, that's the same thing. So suppose, for instance, I know I'm at the point 3, 4, which is up here. So I know that spot in rectangular coordinates. How am I going to find that in polar? Well, I recognize I'm on some radius, and I can recognize that fact because, once again, I've got a right triangle in my hands. Ain't that a beaut? Let's try that again, actually. So it goes to 3, goes to the origin. Okay, beautiful. That's totally a right triangle. You can tell because I got the right angle there. So we know that this point right here is 3, 4, so this base is 3, and this height is 4. So if you want the polar form of this, we need this value for r, and this value for theta. Let's try that bit again. We need this value for r and this value for theta. And I hope and pray very hard that you are able to do that at this point. Right? You better be able to find r. You can find that via the Pythagorean theorem. And you can find theta because you're given opposite to adjacent. You've got tangent of that angle equaling 4/3, so that angle then is the arctangent of 4/3. And indeed, that is how you go from polar back to rectangular. You use the fact that you're on you use the Pythagorean theorem basically, right? R squared is x squared plus y squared, and if you know x and y, then you know r. And then also, because tangent of theta is the ratio of y to x, you can get your appropriate reference angle, right? Arctangent of y over x gives you the reference angle, and then you can superimpose whatever quadrant you're in to get theta. And that's all you have to do, right? Use the appropriate conversions using the Pythagorean theorem and right triangle trigonometry, and you've got your rectangular coordinate based on the polar. So we'll take a couple of examples here. I've got A being 6, 8, so a little bit further out than the 3, 4 guy. And we'll get 10, which shouldn't be too surprising because that's double 3 and double 4. And so that's 10 being my total distance from the origin. And the angle of rotation is 53.13 degrees. And so that actually gives us theta for the other one as well. So I have another point for us, -4 comma -3. And you do the same thing, you'll find radius to be 5. And so the question I want to leave you with is, does that mean that theta, being the arctangent of -3 to -4, is going to be 73.61 degrees? So think about that for a second, take into account everything that we've just mentioned, and give me your response, and we'll kind of say a little bit more, and that will be it for now. And no, theta is not 73.61 degrees. That is because, well, we know we're in the third quadrant. Theta can't be just 73.6. That puts us in the first quadrant. To be in the third quadrant, we have to be at least 180 degrees. In fact, this angle we found was the reference angle. Let me redraw this now. Redraw this. So our point now is -3 comma -4, I believe it was. -4 comma -3, which corresponds to 4 comma 3. Right, there's 4 there, there's 3 there. There's our reference angle there. And that needs to correspond to -4 comma -3. And so you see, when you do your inverse trigonometry, your arctangent, you don't get all of this, right? You don't get all of that. You just get your reference angle. And so we take our reference angle and we add 180 degrees to that, and that will give us the angle we need. And there we have it. So that should do it for us. Let me know if you have any questions, and I will see you up ahead.